Hello, in this video we want to do an indeterminate form which is suitable for 15 and 16 years old and above, for the faster streamed students. Okay, and the object here is to find the limit as x tends to 0 of the function sine cubed x over x times 1 minus cos x. Now there's a little preamble here saying it is always tempting to go directly to L'Hopital's rule when faced with such a problem, but it is sometimes a lot more efficient to take another angle. Now, if we use L'Hopital's rule, in other words, differentiating the numerator and denominator separately and seeing if we have a limit there, what we would get on the top is 3 sine squared x cos x over 1 plus x sine x minus cos x. So already it's looking more complicated than the thing that you started out with. And if you carried on and on, you would get further lengthy expressions and leading to some frustration. So instead, try the following approach. So limit as x tends to 0 of sine cubed x over x times 1 minus cos x is equal to, and we'll split that up as two factors, as the limit as x tends to 0 of sine x over x times sine squared x over 1 minus cos x. Now, when x tends to 0, sine x over x tends to 1. So in the next line, we have the limit as x tends to 0 of 1 times 1 minus cos squared x over 1 minus cos x. The 1 minus cos squared x, of course, being identical to sine squared x. And then in the next step, we factorize the top, which will be 1 minus cos x times 1 plus cos x, and down below you have 1 minus cos x. So the 1 minus cos x is cancelled out, and that leaves us to find the limit as x tends to 0 of 1 plus cos x. And as cos x tends to 1 when x tends to 0, that limit is 2. And that does it. Thanks very much for listening.